Alright, welcome to the second part of this tutorial on how to host your website for free on the same IP with different domains. On the first part, I showed you the easiest possible way, in my opinion, with Spring Cloud, and this worked very well. We didn't even have to write a single line of code, but we have some problems there. The obvious one was the multi-part encoding was not supported, and the other one is performance, because Spring Cloud is basically just a server running below that. It means that it will read the whole request and then it will forward it, which takes some more time and makes things generally slower. And in this part, we're gonna do it from scratch, build it ourselves, so that we won't read the whole request. We'll just forward it to the actual server that is responsible for handling the connection, and we will just read few lines just to get what we need to determine to which server to send it, and that's gonna be it. So with that being said, let's dive into the coding part. Before you continue, actually, I just wanna say that I highly recommend you watch the part 1 of this tutorial, and also I highly recommend you watch my other video on how to parse HTTP requests. I'll leave a link for those in the description. Here in this video, I'm gonna show some coding, but some things are already written because otherwise it would take like 3 hours to do it. So I would highly recommend you check those out, especially the reading for HTTP requests, because this has a few trickeries there. Also, if you don't want to write the code yourself, you just want to use the application, after I'm done, as always, I'm going to commit this into GitHub, so you can just skip to the part where I show how to deploy this code and just download it from GitHub and deploy it yourself, and you'll be ready to go. Now let's continue to the code. As I said, I have few things already prepared, something like a skeleton, because otherwise it will be a lot of time. So let's go through the things that I have added. Let's start with the POM file. So here we have build, repository, and dependencies. Let's start with the build part. We have just this plugin for creating an executable jar file, which will come in handy on the deployment part. We have this local repository, and this local repository can be found here. I just have this library. It's from another video of mine, how to create an IOC container. But basically I just added the jar file here so we can use the dependency injection in our project. And those are the dependencies. We have one block, we have my IOC container library, we have JSON data bind. This is for, we want to read some JSON and parse it into an object, so we need that. We have some login here, and that's pretty much it. Let's go through the resources. This is a config for log4j, and this options file is pretty much the same as in the properties.yaml file in the Spring application. Basically here we define the host, we define any subdomains if we have any, the destination host and destination port. So basically if someone reaches to us from aa.com, we will redirect him to localhost 8000. If someone reaches to us from this IP, we will redirect him to localhost at 8080, and so on and so forth. Right, so here in this API folder, we have two interfaces, the connection handler and the option service. Those are not implemented. We'll implement them in this video. Connection handler has just one method called process, a socket, and socket will be a connection from the client. Option service has just one method to get options, and the options are, of course, the values from this JSON file. Here's the class for the options. We have basically the same thing that we have here, but just in Java class variant. Config, we have this bean config, and we have just this bean for object mapper. Again, this is not Spring, this is my custom library, but I have used the same annotations, that's why it looks like Spring Boot. We have a bunch of constant variables here, predefined. Those are few paths. Basically, this is the working directory. We'll use that later on for various things, but I just added them beforehand so that we don't have to write them while I'm explaining other things. And these are a bunch of things that we also need later, like the settings file name, and also we will be able to import our options through an environment variable. That's why I added this as well. And few other things like the server port and this read buffer size, which is for transferring the HTTP request from one another. We'll use buffer with this size. Here we have just a custom exception, and in these util files we have utility classes for parsing HTTP requests. So again, I won't go through that class in much details here, but if you're interested, you can watch my other video. It's basically the same thing. We just read from input stream that is coming from a TCP socket, and we're making a few things here. And that's pretty much it. The startup class has just this system out print saying that the application is running. So let's just make sure that is the case. Yep. So this is pretty much what I've done so far. We have some work left to do. And the first thing to do actually will be to create our logic for loading the settings. So I'll just go ahead and create an implementation. All right, we said we want to load the options from either the resources folder or from the environment variable. So let's do the conditional check here. I'll say string options equals system get environment. And here I'll just pass the constant from general environment variable option name. And here I'll just check options equals no. Then I'll return this read from file. Now I just want to print here walk info, and I'll just say reading from resource file, or probably reading options from resource file, and I'll add the file name just like that. Settings file name. Yeah, here it wasn't as, but it was like that. All right. And in case there are options, we'll just say walk info reading options from environment variable, and we'll just return this read from environment variable, and I'll just pass the options here. Now let's require object mapper here because we will need it. And I'm just gonna add required arts constructor so that we don't have to create our constructor. And here's the implementation for reading from file. So we create a file input stream, and here's the path. We have the working directory coming from the constant file and the settings file name. We'll basically, that way we'll reach this options.json. Then we'll just use object mapper to convert this file into our list of route option, and we'll return that. And if there's any sort of exception, we'll just print that something went wrong, and we will let the final user of our application know about that. And here is the implementation for reading from environment variable. So we get the options which we already read here. we won't have to read them again. And we'll just use object mapper again to read the value, but not from input stream, this time from a string, and again convert it to a route option. If there's anything wrong, we'll just say that there was something wrong, and that's pretty much it. Now we have to test if this works. So I'll just go into app startup here, and I'll just say private funnel option service, just like that. And I'll use a constructor this time, like that. And here I'll just print this service, get options, and run. So as you can see, we do get the proper values. We have everything that we have in this file. So this is all good. Now we should probably test this with environment variables just to make sure it works too. To set up environment variables, here in IntelliJ, you open the run configuration. If you don't see environment variables, click on modify options and you find them. Then just come here and add your options environment variable, add your JSON object. In my case, I added the same, but only the first one, not the second one. So let's run. And here you see it says that reading options from environment variable, and here are the values. Now let's do some work on our startup class. First, I'll just clean a few things up because we don't need them anymore, like that. All right, so in our startup class, we'll have to create a thread pool. So final executor service, I'll just call that pool. Let's create just a pool of 10 threads. Now, if you're really chasing performance, you might make this optional, not fixed 10 threads. You can make it whatever you want, but for our case, this will be fine. And also we have to define a server port. So I'll just create a method called get port. A final int port, I'm sorry. And here I'm gonna add this method. Right, so it checks for environment variable for port. If there is no environment, if there is such environment variable, gets it. Otherwise, it uses the default port, which is port 80. And now we are gonna create another thread which will listen for connections. So I'm just gonna say new thread, and I'm just gonna call that start method so that the thread starts running. And here, this is the logic that will be executed in this thread. So we just print that we start listening on a specific port. Server socket is the standard way for listening for connections in Java. This is also explained in the video for reading, parsing HTTP requests. Here we have this loop, which basically server accept will wait until a connection comes from the client, and once it comes, basically once someone tries to access our website, we will get this client socket, and then we use the pool to handle the connection, and we'll use our connection handler process to handle the content of the request. And here I'm just gonna say private final connection handler, and I'm just gonna add required parse constructor, and that's pretty much it. Now we only need to implement this connection handler, and we should be ready to start testing our application. But yeah, as far as for the startup class, this is pretty much it. We don't need anything else. And once this client is passed to this connection handler, we can get another client, and this happens asynchronously, so like 20 clients can be processed at the same time, so that's good. All right, so let's create an implementation. So this is a service, has required Rs constructor, and it also implements connection handler. First thing I'm going to do is I'm going to require the options service so that we know from where to get our information to which domain to route. And here I'm just going to say private static class destination DTO. And this class will have private int port and private string code. It's gonna be a data. This is the annotation from one block, and all Rs constructor and no Rs constructor. I'm not sure about those if I need them, but let's just have them there. And we'll also have this private final map string and destination DTO. We're going to call it domains map, close new hash map, just like that. And here I'm just going to add this comment, and also I'll explain what this thing will hold. Also, if you don't understand it from the comment, basically as a key, it will hold the domain from which the website is coming from, basically abc.com, for example, and then the destination DTO is going to be to the which internal server we want to call from that domain. And the destination DTO has port and host, and if you go to options, you will see that we have this destination host and destination port. So basically those are the things that we're gonna be getting there. And actually now we have to initialize this whole thing. So let's create post construct void init, and inside here we're just gonna populate this domains map. So we're gonna start with getting all the options. So this service get options and store them into a variable options. Now let's go through each options, and for each option we're gonna create destination equals new destination, and here we need to pass the port and the host. So option get destination port and option get destination host, and here we can say this domains map put option get host and then add the destination. Basically for this host we want to have this destination, and there's only one thing here. We have to say option get subdomains and iterate those two, and for each subdomain we need to do the same. So this domains map put subdomain plus dot plus option get host and then add the destination. Basically if we have www.aaa.com, we have to account for that too. That's why we're adding the subdomains here as well. And yeah, this is pretty much it. Now we'll have a populated map of domains. I don't like this sticking too much, so I'll just rename this variable to test, and that's better. Now let's implement this process method. The first thing we're gonna need here is the input and the output stream to the client. So let's get those. This throw exception here, so I'm actually just gonna wrap this into a try catch, and here say get IO exception, and inside here I'm gonna say log error. Oh, sorry, I forgot to add cell for J error, and here say error error right processing client request and pass the exception like that. And here we need to close the socket. So, socket close. And here we have to catch another exception. So I'm just gonna say surround try catch. And I think here we can safely ignore this exception. Just like that. And before we proceed, I think it will be much better if I show you exactly what we're aiming to do here. If you haven't watched part 1, when we load a website, you can see we're sending this host here, abc.com, and in this case at port 770 because I specified that here. But anyway, we want to get this host, and depending on the host will determine to which destination we want to go. So imagine that we will have 4 applications running at different ports. So localhost 8080, 8090, 9090 and stuff like that. And based on, let's say, ABC, we want ABC to go to 8080, we want XYZ to go to 9090 and stuff like that. And that's how we understand the actual domain name through this header called host. So all those settings do exactly that. We have this host coming from the client, and then we have the destination, which is localhost or whatever. We can even specify an external server, just how I'm going to do in this video because I don't have any websites running. So let's continue with the implementation. So as we found out, we need to get the host header. So I'll just paste that and quickly go through it. So we have list of string metadata. Basically, this is these are all the headers that we have. And how we get them, we try to parse the metadata lines. If there's an error, we close the connection. Then we convert the metadata lines into actual headers. And from there, we can get the content length, we can get the host, and finally we can check if the domain map doesn't contain that host. Basically, our shared hosting doesn't work with that domain, and we close the connection. So how we parse the metadata lines, just quickly to go over that. Basically, we get this input stream and we read byte by byte until we reach the end of the headers, and the end of the headers is always a new line. So if we reach a new line without anything else, that means that we reach the end of the headers and we start going into a request body, which we don't want because we don't care about that. We only need to get the headers. That's what makes our application faster than the Spring one, because Spring actually continues reading through till the end. And then we go back here. And then we convert this into headers. Basically, this is a list of the wines, so not parts, basically host, double column, and then the host name, and we convert that into key and value. So the key is host, the value is the value. The content length, so here's exactly how we get that. We search for a content length header into this map. If there is, we get it. Otherwise, we use the available data from the input stream, which is actually not correct, and because it's a TCP socket. But just in case we don't get it, we default to this. And then for the host, it's pretty much the same thing. We try to get the host header. If there is no header, we try to get it from here, but this doesn't quite get the job. So we really hope that we have this header sent. And then this is as simple as checking if we support this host. If we don't support it, we close the connection. Now let's do the exchange between the server and the client. So I'll just say destination server equals these domains get, and here we need to pass the host, and we need to open a connection to the server. So server connection equals new socket, and here we need to pass the host and the port. So server get host, server get port. The next thing is to do the exchange between the client and the server. So I have a utility class for that. HTTP protocols utils transfer HTTP request input stream. This is the client in metadata content length and the output stream. Now the output stream is server connection get output stream, and this way whatever our client sent to us now is gonna go to the actual server that is gonna process the connection, and naturally we want to get the response and forward it back to the client. So let's say HTTP protocols utils transfer HTTP response, and now the input stream is gonna be the server connection get input stream, and the output stream is going to be the client out. So basically get what the server has to respond and forward it back to the client. So let's quickly go through and see what those methods do. So this, because we read the metadata and the server needs that, we're gonna convert this list of string into a valid HTTP headers. So that's what we do here. We join by a new line, write that, and then if we have content length, we continue to read from the input stream, which comes from the client, and write back to the output stream, basically the server. Now here, what's interesting is the nature of the TCP socket, so we need to await that, but that's topic for another video. Again, you can watch my video for reading HTTP requests, you will understand that. But let's see the transfer HTTP response here. Now, again, because of the nature of TCP sockets, we need to have the content length, and that's why, again, here we need to parse the metadata coming from the server's response. So we do that, and we get the content length, then we convert it back to the proper HTTP format, write that, and then use the content length to read the rest of the HTTP request. Because otherwise, if we don't have the content length, we don't know how much to read, and this will basically break our connection. So this is not going to work. I mean, this is all we need to do, but it's not going to work because the way we did it is not correct, because again, TCP connections are asynchronous, and basically what we do here is we send this and expect not to get any response until everything is sent, and then instantly after that receive a response, which is not how servers work. This all has to be asynchronous, so let's make it asynchronous and we will be ready to deploy this. I'm adding this code snippet here, code connection, run async socket connection, and this interface called runnable throwable, and let's quickly go through that and see what we have. So we have as a parameter here, we have a runnable, we have two sockets, the client and the destination, and this boolean which is close on finish. And basically what we do is we run a new thread where we execute this runnable, and if there's exception, we close the connection. And if we have close on finish set to true, once we're ready with this, we also close the connection. And close connection basically is this. We call the close method on those two classes. Now, how we're going to do that? We're gonna call this two times, once for the request and once for the response. So async socket connection. We need this runnable here, so I'm just gonna pass it like that, and I'm just gonna say this, and I'm just gonna make a static import so that we don't take too much space. We took space regardless, but anyway. And we need few more parameters. So we need the client socket and the destination socket. So the client socket is basically socket, and the destination socket is the server. And we want to close on finish, pause, not on the request. Sorry, this is server connection here. And yeah, we don't want to close on finish, not in the request, because while we're sending the request, we still want the connection to be open so that we get the response too. And now let's do the same, this async socket connection. Let's get that, paste it here, do a static import. Forgot to pass the lambda, like that. And here we can say, again, we need the socket, we need the server connection, and here we're gonna say true. And this is true because as soon as the server sends the connection back and we read it and we transfer it to the client, we no longer need this connection. So close on finish is true in that case. And with that being said, I think we are ready to test this and see if it works. Now let's create some domains here. I've opened the host file in system32 drivers etc hosts, and I've added those 3 entries, website 1, 2, and 3, which both lead to 127.0.0.1, which is, in other words, localhost. Basically, whenever we write this in a browser, it will interpret this IP, and we'll use this for testing. Now, just to show you, when we open this, nothing will show. Let's go to the options here, and let's see what I've said here. So I said website 1.test will lead to this IP at port 7070. This IP is from my other computer, which is currently hosting few websites, and website 2 is going to lead to the same IP but a different port. And just to show you here what this thing is, so let's try 7070, we get this site. Let's try 7090, we get this site. Now let's go back here and let's run. It says try port 80, it succeeded, and now it's listening for connections. So in theory, if we go here and try to type website 1.test, as you can see now we want this website from my other computer. And here, if we type website 2.test, as you can see, we want the same website as if it were directly calling the IP. And actually, that's pretty much it. As you can see, it's working, and we don't need to specify any port because it's there. All the domains are working on port 80, and that's pretty good. Now, if we have to compare this to the Spring, this website actually has option to upload and download multi-part files, and it's working here, whereas in the Spring it didn't work. And I've also done some performance testing, and basically our application that we just wrote is quite faster than the Spring's one, which is to be expected because we are not doing any processing of the request. We're directly sending this to the server. Now for deployment, I'm going to show 2 ways. First way is using Maven, and the second way is using Docker. So for Maven, make sure you have Java and Maven installed. Go to the root directory and just type maven package. Wait for this to compile. And once it's done, go into the target folder, and I'll just open an Explorer here, classes, and we have this run.bat, and you can basically click on that, and as you can see, the application will start running and it's working properly. Now this run.bat file, basically this is what it is. it calls the Java command, passing the startup class, and starts working. This file will be uploaded in the repository too. And for Docker, here's the Docker file. Again, I'm gonna commit that into repository, but basically you just need to go to the root directory of the project and just call maven build, and it will create an image for you. I'll actually show you that on my other computer. Here's my other machine. It's running Linux, but it should be pretty much the same. Here's the folder of the project. Here is the command docker build, the name of the image that we want to have, the version, and dot for the same folder which the Docker file is contained in. And just before I do that, I want to just show you that all the images that I have in Docker, you can see that I have no domain router image, and I'll click enter to run and wait for this to build. Right, it's ready. Now to run it, I'll just have this docker run domain router, make sure the network is host, and then specify the version and the name of the image. Network host is important because you need to be on the same network as your current computer so that localhost and all the other things work properly. Now click that and it's running. Now here you can see that domain router showed, and here domain router is also running as a container. Alright, so this is 1 year later. I decided to finally edit this video, but after I did it, a lot has changed. So this is the code here, as you can see, 8 months ago. But I ended up using very similar solution in a real world application. So I wrote this repository, this project, which is same as the other one, but with a lot more features. This one supports SSL. This one supports keep alive connection. So whenever you connect to something, you don't have to create this new connection every time. This supports thread pool, and as you can see by just the options file, it's crazy here. You know, you have these certificates. You have those things here. But yeah, if you wanna use this for like real application, I strongly suggest you check out this one as well. I will leave a link in the description. And yeah, there are even other things done here. Like for example, if you're using a proxy server, this one is a bit tricky, so I added fix for that as well. So yeah, it's interesting. I suggest you check that out as well. But yeah, with that being said, this is the application. I'm still using it till this day on a real world application, so it's working very well. So yeah, hopefully this was helpful for you guys. Thank you for watching, and hopefully I'll see you next time.